Alright class, in this video I'll be doing the first example from section 5.1. Create a polynomial function whose degree is 3 with zeros 4 with a multiplicity of 2 and x is equal to negative 3. So I'm going to start by explaining some of this vocabulary here. The first thing I underlined in black was degree is 3. And what that means is that the largest exponent in the polynomial should be 3. What I underlined in purple is the word zeros. And what that means is that a 0 is the value of a horizontal intercept. And in this case, we're going to call them x-intercepts. So let's begin. It says one of the zeros is 4, but it has a multiplicity of 2. So I'm going to write that 0 out twice. And then the second 0 is negative 3. So what I've done was I listed all the zeros. Now I'm going to create their corresponding factors. So I'm going to do that by subtracting 4 from each side of the equal sign to the expression on the left, subtracting 4 from both sides of the equal sign and the expression in the middle, and by adding 3 to each side of the equal sign to the expression on the right. This x plus 3 is the corresponding factor to the 0, x is equal to negative 3. To create the polynomial, I'm going to multiply all 3 of those factors together. So to create the polynomial, I'm going to multiply all 3 factors together. So that is equal to x squared minus 8x plus 16 times x plus 3. And we're going to multiply those two polynomials together. So that is x cubed plus 3x squared minus 8x squared minus 24x plus 16x plus 48. So I'm going to label the polynomial f of x, and that's equal to x cubed minus 5x squared minus 8x plus 48. Now what I would suggest is that when you get this polynomial, that you use Decimus to graph f of x to see if f of x has the given roots. If it does, then you did the problem right. If it doesn't, then you did something wrong, whether it's in your arithmetic or whether it's creating the factors or whether you had the right roots.